Pardon me?
It's shale, not slate.
Well, it was originally quartz sand here, and originally shale. And it was deposited in about 1.7 billion years ago. 1.7 billion years ago. There's some difficulty in dating it because you really cannot date sedimentary rocks easily. There are associated igneous rocks that are used to bracket the age. Underlying rhyolite, granite, and overlying rhyolite, I believe. So 1.7 years ago, these were sedimentary rocks. Remember, Proterozoic. Quartz sandstone, a very mature sediment. So it has to be Proterozoic. If I say a Precambrian sediment that is very mature and a quartz sandstone, you know immediately it cannot be Archean. Archean sediments are greywackies, overwhelmingly. And I don't know if there are any. So this is actually about early to middle Proterozoic, 1.7 billion years. So it's pure quartz sandstone that was deposited on a stable shelf in the Proterozoic at a time when the continents were getting their modern granitic character. And all this quartz here was derived from the granite core of that Proterozoic continent. And well, now we have metamorphic rock. We have quartzite, we have slate, or schist, really. It's not phyllite. It's actually a phyllite, between a slate and a schist. But they were metamorphosed, folded. They were folded and metamorphosed about 1.6 billion years ago. And the folding, of course, the pressure must have been from what is now north to south to cause this syncline. But it's more complicated than that because it's a doubly plunging syncline, meaning it's inclined in all directions towards the center. It's like a bowl. And I'm not going to try to explain that because it's beyond our interests here, and I don't want to numb your minds any more than I have to. But you can read about it in some of the one of the handouts by it's the handout on the structure issues of the variable. And actually, we might get Sarah to talk about it here in a second. But all right, so it was folded and metamorphosed to quartzite and phyllite about 1.6 billion years ago. So it involves some compression, and it's related to Proterozoic plate tectonics. I think Sarah's going to talk to you a little bit about that. But I want to call your attention here to some features. These lineations here, these lines here, these flakes, these things here in the shale, in the quartz. You don't see them in the quartzite. Sarah, you're going to talk. Where's Sarah?
I'm right here.
Oh, there you are. Okay, you're going to talk about it because I'll just stop.
What do you want me to talk about?
Well, this cleavage here, this rock cleavage here. This rock cleavage. Okay.
So how it was created?
I'm not certain how it was created, but its geometric orientation relative to the axial plane of the fold.